Today we are going to be taking notes on solving equations. I'm going to be demonstrating the tape diagram model as well as the algebraic procedure. Our goal is for everyone to move to the algebraic procedure eventually. However, some of us need to stay with the tape diagrams longer. Some problems are more complicated, and we need to have that as a tool that we're able to pull out should we need it. Remember, as we're taking notes, anything that I write on my piece of paper should be written in your piece of paper. And remember, there's different methods of taking notes. Some people like to listen to the notes first, then push pause and copy things. Some people like to copy it along with me as I'm going. That's the beauty of the video, in my opinion, is that you can watch it and then rewind it if you didn't catch something. You can watch it and pause it if you want to write things down. So really make this work for you so that you can get the best out of this information. So the first one we're going to do is something like a 16 equals y plus 3. And I'm going to be using pretty simple computations today so that we can really focus on what's happening and you can really see them, knowing that we could really use this strategy for any equation that we come across should we need it. So first thing we want to do is the tape diagram model, or our visual of these. And I just kind of read the equation to myself. 16 is the same as y and 3. So when I draw it, I just pick an amount for 16. And I've learned that it helps to put the 16 up here instead of in the box so we can kind of work within the box if we need to. And then it's the same as y and 3. And as I did this, I noticed 16 is pretty big. I don't know what y is, but I know that 3 is pretty small. So if 3 is small, then that means that y has to be more of the 16. So I have this being a little more meaningful. So that helps me when I get my answer. If I get an answer of 1 here or an answer of 2 here, I know that that's going to be not correct. Some problems, we don't really know how big to make these, and then it's okay just to kind of make them equal or try to just put them in as a picture. But when you can make them meaningful, that always adds another level of understanding in there. So as I'm looking at this problem, if I need to know what y is, then I need to figure out what it's equal to or the same as. So if I draw a line right here, because I know if this is 3, this has to be 3, then whatever is left over here will give me what y equals. So now I'm thinking, what is the, so if I get rid of these 3's, then that'll leave me with what's left over on this bar diagram and what ultimately is left over here for y. So I'm going to take 16 minus the 3. That leaves me with 13 right here. So if 13 is this piece, then y is the same as 13. So y has to equal 13. Make sure when you do your tape diagram models that you are solving them within the tape diagram. So that'll be another check for you in the equations when we do the process side of it. Another way to think of it is this is 2 number bonds. Once I have 3 here, what is the other number that goes with 16 as a number bond to get you that 16? It would be 13. So in the model here, now let's do the algebraic method. I hope I'm spelling algebraic correctly. On the algebraic method, again, we start with the 16 equals y plus 3. Now I visualize this as a balance, one of those pan balances that you use in science class. And on this side I have 16, and on this side I have y plus 3. That's why I like to separate it with a line so we can kind of see what's happening on this side of the balance versus what's happening on this side of the balance. So again, just kind of picturing that balance beam here of here's a tray and here's a tray. Hope that helps. So based off of my visual model over here, what did I do? Well, I took away 3 from each side. Mathematically, how do I take away 3? That's subtraction. So I'm going to do 16 minus 3, and I actually do the math in this process here. 16 minus 3 is 13. Then I got to think about my balance. If I took weight off of this side, it makes it a lot lighter, so it's going to go up like this. It's no longer balanced or equal, the same as each other. So I need to make this side lighter as well, or I need to get y by itself. So I have y all by itself. How do I do that mathematically? Again, I'm getting rid of this 3, minus 3. So 3 minus 3 is 0. Y plus is still in that pan, and it's back to balanced because I've done the exact same thing to both sides. So 13 is the same as y plus 0. Well, we know that if I have y plus nothing, it's basically like having y. That's the identity property of addition. So if I have y plus nothing, so I basically have y, I've solved my equation to be 13 is the same as y. You always want to do a check, and that's also why I like algebra, is because there's a way to check it. So if 13 is the same as y, you can do that old substitution method. Coach says y, you're out. 13, you're in. So you do 13 plus 3. Actually solve it. 13 plus 3 is 16. 16 is what I have up here. So check, it is correct. Now let's do a subtraction problem. What if we had d minus 8 equals 10? So on this tape diagram, remember we're thinking about part, whole. So when I think of this equation, which one is the whole? In this case, d is the whole. And then in my mind, we go back 8, so we take off 8 here. And our other part we're left with is 10. So I love this model because right away the answer to D should be glaring at you. Because if D is the same as 10 and 8, isn't it just 10 plus 8 that will get us what D equals? So D should equal 18. So now let's do that algebraically. If I have D minus 8 equals 10, here's one side of my pan balance. Here's the other side of my pan balance. What did I do in my visual that will help me with the algebraic process? Well, in order to find D, I had to add 10 plus 8. So right here, 10 plus 8. And again, do the actual math. 10 plus 8 is 18. So thinking about that balance, if I add weight, it makes it heavier and it's no longer balanced anymore. So I have to add weight to both sides. So since I know that I added weight here, I need to also add weight here. So I'm showing I did the same thing to both sides. Check. That keeps it balanced. Mathematically, what I'm doing on this side is if I owe somebody $8 and then I give them $8, I now owe them $0. I still have D minus, but now I'm taking away nothing. It's back to being balanced, so I can say it's equal because D minus 0 is the same as 18 because I did the same thing to both sides. So again, identity property of subtraction, if I'm not taking anything away from D, then I simply have D. So that tells me D is the same as 18. Again, we can use the substitution method to do our check. So we take the 18, we sub it out exactly for that D. We have 18 minus 8 gives me 10. That's what I'm supposed to get. So check, that works. Now let's look at a multiplication problem. If I have 3W equals 15, what does that mean? Hopefully, after all these weeks, you understand that this is juxtaposition. Side by side, multiply. So this is 3 groups of W. So when I draw that, I draw 3 groups of W. So this is a W, this is a W, and this is a W. Is the same as, is equal to, so we're going to do this is the same as 15. So now, how can I figure out what's in each of these boxes? Well, I need to take this 15 and split it evenly between these three boxes. Mathematically, if I'm taking this 15 and I'm splitting it, that means I'm dividing. So 15 divided into those three boxes is 5. So that tells me that each of these boxes is 5. So therefore, W equals 5. Again, you can see the 5 plus 5 plus 5 is 15. So you have that nice meaning there in your picture. Algebraically speaking, 3W is the same as 15. So again, we have this side of the balance and this side of the balance. What did I do to 15? I divided it by 3. So I take 15 divided by 3, and I have to actually do the math. 15 divided by 3 is 5. Over here, I do 3W divided by 3. Well, 3 divided by 3 is 1W. Since I've done the same thing on both sides, I have got it back to balance. This is the identity property of multiplication. 1 times anything is going to be that thing. So one group of W is simply going to be W. So W has to be the same as 5. Again, I can do my check, plug that back into the same problem. 3 times 5 equals 15. That's what I should get. So check, I got that correct. Last one, we're going to do division. So now let's do D divided into 2 pieces equals 18. So when I take D and I divide it or cut it or split it into 2 pieces, I get 18. So D is the same as, or D after I divide it into 2 pieces is the same as 18. So that's a little confusing, but that tells me that this piece right here is the same as 18. So if this piece is 18, then that means this piece has to be 18 and this piece has to be 18. So now to figure out what D equals, I have 2 groups of 18. 2 groups of 18. I can do that off to the side here. 2 times 8 is 16. 2 times 1 is 2 plus 1 more, 36. So I have D is equal to 36. Looking at algebraically what I did, D divided into 2 pieces is the same as 18. Well, I had to do 2 groups of 18. So what I did is I multiplied by 2 on this side, and I multiplied by 2 on this side. This is really like a fraction times a fraction, so I put 2 over 1. These cancel each other out to get 1. So I have 1D equals 36. So therefore, D equals 36. I always want to do my check, so I plug it back in. 36 divided by 2. I would literally do that math. 36 divided into 2 equals 18. That's what I needed, so therefore I got that correct. Now, look at these and see what connection you see. Here we had an addition equation. What did I do here? Subtraction. Here I had a subtraction equation. What did I do here? Addition. What do you notice about addition and subtraction, subtraction and addition? Hopefully you said they were opposites. Those are called the inverse operations. So to solve for addition, you do the inverse operation, which is subtraction. Then if we look at our multiplication, what did we do to solve the multiplication? We did division. In division, what did we do to solve? We did multiplication. So when you're solving equations, you use the inverse operation to solve or undo what's being done in the original equation. And we'll talk about that more and look at that process more when we are finished. or in our next lesson rather. Have a good day.